I work in an organization called UI Engineering at Netflix. And what we do is we try to make better user experiences. So we improve our UI every time we can to give the users a better experience. And the way that we do that, it's not just, oh, I think that this UI is much better, let's ship that for millions of users and see how it goes. We do a lot of A/B tests. And A/B tests are user experimentations that we run. We create 20 different UIs, and you put everything together in one screen. We test with multiple users. We see which one works better, and that's the one that we ship. In the player UI, if you guys watch Netflix, we did a test with that, and we test a lot of different things, and that was the winner. So you have the best experience of all that we tested. But there are some technical challenges with that, especially because we need to make 20 different experiences work in the same screen. And we have to keep the old experience working without breaking that. And there are millions of users that are using that. So how do we do it? This is one illustration about the player. Some things that we tested for the player, if you remember in the left, we had our old player UI that we had for a long time, and then we decided to make it better. So we tested a lot of different variations of that UI, and if you see in your left, every single orange box is a UI portion that we played around, we moved it, we tried different ones to see which one works better. So here it's just an illustration, but we might have 20 different ones that we have to support at the same time. And we cannot break the current one because everybody's using that. So what do we do? How do we code that? That's the hardest part. So there are some approaches that we can use. The first one would be, and the simplest one would be a giant XML layout that has all the permutations of all the UIs in a single one, which is very hard to maintain and to implement. So think about that. If we have the same button in the top and the same button in the bottom, we have to have some code that will deal with that. If the user is in the experience A, we put in the bottom, we set the visibility to visible, and we set the gone in the bottom, and we can have bugs like 2 buttons that are exactly the same showing up to the user. And we have a bunch of if-elses and etc. So perhaps we can try something else. We can try one layout per user experience, per variation of the user experience that we have. So then we are going to have 20 different XML layouts. We can copy and paste that and change accordingly to reflect what we want to test for every single experience. The problem is there are lots of duplication of code. And I'm pretty sure you all know that this is something bad. If you have to fix one bug, you have to fix in the 20 different layouts that you have. And that's pretty hard to do. We can also play with programmatically layout and have all the views created, inflated on the fly, and then we don't have XMLs. But then there are some people that really like the Android Studio XML editor, and I really like that. It's very nice. So you can play and you can visualize with that. You kind of break this possibility if you go to the programmatically approach. And this is only layouting. Let's think about the code. Where do we put the code? Probably the player screen is a fragment or an activity. And if we put all the code there, it will be like if experience A, do ABC, else if experience B, D, C, D, E. And then we have a lot of ifs. In every new code that we add to that screen, we are introducing risk for the current experience that it's out there. We could break the current experience if we touch the same code. So we could organize it better. We could have one class per test cell, and then we can use inheritance or composition, one of these approaches that will make a little bit better. So what is our dream? You folks may be thinking, what does this guy want? what he really wants. Maybe he wants something that doesn't exist or doesn't exist on Android. Like a floating island in the middle of the ocean, maybe, I don't know. So, but what we really want is we want to be able to test our UIs. Testability is very important for us. We want to easily write unit tests for everything that we create. We also want to reuse. Whoops, come on, reuse. We want to reuse stuff. So it means that if we have the same UI across multiple screens, we want to get that piece and put in another screen without any crazy code or without any dependency. We just need one line of code. We want one line of code that we put in another fragment and the UI is there. We don't have to do anything more. We want also to maintain that. If we fix a bug, we don't want to create two more. We want that thing to be clean. And of course, we need to extend, because we might have 2 or 3 A/B tests running in the same screen at the same time, that 3 people are working in the team, and then we need to support that. So how do we get to all these things? Componentization is one architecture that we tried to achieve all these things. So the idea is the UI can be composed by multiple components. And when I say components, I'm not talking about Android fields. I'm talking about something bigger that has all the logic and all the data that it needs. And we could have, if we think about this idea for A/B tests, we could have different components per experiences that we want to provide. Or we can compose experiences using the same components that we have, and that will be much easier for us. As I showed you before in the player screen, maybe the component, sometimes the component was in the bottom, sometimes it was in the top, and then if we have components, we could move it around. We could just use the same one and move them around. In the layout, we could have every component be responsible for its own layout. So we don't need to create crazy stuff with multiple things and see how the layout works. We have the layout very isolated. So here is one example, what it looks like. This is the new player UI. I hope all of you are familiar with that. Here, the approach that we took is we created 4 components that you are seeing in the screen. The first one is the top bar. So the top bar has 3 Android views, but for us, it's a single component because it makes sense. There is no rules. It's very flexible. It could be one Android view. And then we have the component in the center. We have the scrubber, and we have another component in the bottom. But also, we have the loading. The loading is a component by itself. It will have its own logic. It will show up and hide based on its own business logic. And we also have more stuff in the player. I couldn't put everything here, but this is when you binge watch. We play the next episode automatically, and that's a UI component as well. So let me stop a little bit and talk about the architectural pattern that we used for this architecture. First, I'm going to talk about the model portion. So most of the talks that I watched about architecture, they focus a lot in the model, and the model is a core of the architecture pattern. In this presentation, I'm not focusing on that. I'm going to the view and the presenter. And we used a mix between MVP and MVI for this architecture. From the MVP, we got the idea of a presenter and a view. And the presenter communicates or calls the view using an interface that the view provides. That will make a little bit cleaner. But we could have picked another approach. There are a lot of different ways of doing that. And the presenter is the one that has the business logic, and it will maintain the state of the view. The view is completely stateless. And the view here is not the Android view. And it's not the fragment. One thing that is a little bit controversial that I'm going to say is the fragment should not be your view. The fragment should take care of the life cycle of the application. And your view should be your view. which is something else. It's not a fragment. So in this scenario, every time I mention the view in this context, I'm not talking about the Android view. And from the MVI, what we got from the MVI is the idea that the views don't have the business logic to process user interactions. The view will fire an intent event, like somebody clicked at me, somebody tried to drag me, and this kind of stuff. Somebody else is going to process this event, and it's going to have the business logic, and it will react accordingly. So here is a high-level architecture, how the high-level architecture looks like. We have a fragment, and the fragment will instantiate all the components. Here we can have a lot of components, 16 components. Every component is a set of classes that could be a view, a presenter, and a model. The model only if the UI component requires its own thing. If you already have the data in the fragment, you don't need the model in the presenter, in the component. You can have just the view and the presenter. And its own layout, of course, as I mentioned before. So every component will have its own layout. Now let's talk about the flow, the communication flow, how all these classes fit together and how they communicate. So we are using RxJava to implement an event bus pattern, but that's not required. You could use any event bus library you like or any approach you prefer. We use RxJava because it's very nice, and with Kotlin, the code looks very clean. So RxJava provides a lot of methods that we can use, filter, map, take until, and all these things will help a lot in this architecture. By the way, on Netflix, we use Kotlin for everything. Every new code that we write, it's all Kotlin. We still have the Java code, but everything new we write in Kotlin. And we use a lot of Rx, especially in this architecture. So we have an undictional communication flow, so it's one-way flow. So there are no two ways communication. All the events, they flow in a single direction. And here we have the fragment in the left that you can see. We have an observable called state events. Every time an event happens, we fire that. And the presenter is going to observe on it and call the view accordingly to set the state of the view based on the state that just happened. State events for us, you can think about in the player context as play started, buffering, play paused. All these events are flowing to all the UI presenters, and they will process the event, they will have the business logic and the presentation logic, and they are going to call the view. View.show, view.hide, view.enable, view.disable, all these methods from an interface that the view is going to provide. And then we have the other observable that we have here. So the user input events. This is the one that I just mentioned. Everybody the user touches in the UI, that view is going to get this event and it's going to fire it. And the one that observes is the fragment. The fragment will observe these events, and we have all the business logic for the listeners to implement and do what it has to be done. Again, if you think about the player context, if the user press the pause button, we need to invoke the player engine to pause that and to make the playback pause. The view doesn't know anything about the player engine. The view doesn't have any references to the player engine. The view just emits an event, intent pause. And then the fragment is the one that owns the player engine, and it's going to react accordingly and make that playback pause. And here the pipes are, if you are not very familiar with Rx, they represent observables. So you can think about that, a pipe diagram where an event goes from one place and arrives in the other one, and there is no other way to get that. That's the only way that you get that event. So what is a UI component in this architecture? A UI component is an entity that is formed by 3 classes, or 2 classes if you don't need the model. So we have a view class, we have a presenter class, and we may or may not have a model. They are very independent. Every single UI component, it doesn't know anything about the other one. So going back again to the player context, the loading screen doesn't know anything about the other UI. And the other UI doesn't know anything about the loading screen. They don't have references, they don't communicate with each other. It's just a matter, they know what to do when an event happens or arrives. One thing that we try to do is to apply the single responsibility principle on this architecture. And it's not really a single responsibility, but we have the main responsibility for every class. And they have more responsibilities, of course. But one thing that we try to do is the fragment is not responsible for finding view by IDs. The fragment is not responsible for setting a view to visible or gone or all these logics. These are all responsibilities of the presenter. So if we take a look what the presenter is responsible for, the presenter is responsible for the UI, the presentation logic, and everything that it has to do with the view, set the state of the view based on the events that it receives, using the view interface that the view provides to the presenter. So it manages the state of the view. The view is completely stateless. And the third one and the last one is one of the responsibilities of the fragment of the presenter is to protect the view. Or I'm pretty sure all of you or most of you have encountered exceptions when you try to do something with a context or with a fragment that it's not valid anymore. So the fragment was destroyed and you are trying to do something, Android just blows an exception and your app crashes. In order to protect of these things, we don't want to add a bunch of ifs. If fragment is alive, you can run that. Or then we have 200 lines of code with ifs to check if the fragment reference is good or not. What we do here is the presenter is the only one that's going to invoke the view. The presenter doesn't have any references to the fragment. It doesn't have any reference to the context or to any Android stuff. It's just a Java. If it's really required. It's not recommended though, but it needs that. I'm going to show you later how the code looks like. But if the presenter is the only one that accesses the view, we can control the observable that we have inside the presenter and tell it, do not fire the view or do not invoke the view. If that fragment is gone, you don't have to do anything. So there is no exceptions anymore because the presenter is going to protect the view. And the view is responsible for inflating its own layout. That's its main responsibility. And why the view has a reference to the context. And that's why we don't want to expose that. And the presenter will protect it. Also, the view will be responsible for finding out the view by IDs and keeping all the Android views. Because a component could be a single view, a single Android view, or it could be multiple Android views. So the view is the one that finds all these things. And it provides an interface to the presenter. The interface is just a basic operation interface to change the view state. It's a show, hide, enable, disable, etc. The view is also responsible for animation. That the presenter is providing, the view should not expose Android views or should not expose any context for anybody. In this sense, it will be protected and we don't have these kind of exceptions anymore. Let's take a look in some code. So here I'm going to start with the fragment, right? The fragment will instantiate all the UI components. And we do that it has an Android view group that it will provide to all the components. And the components will inflate themselves inside this container. So the XML, the layout XML that the fragment has, it's just a constraint layout. or it's just any view group that you like to use. And then inside the fragment, we are going to instantiate presenter1, and the presenter1 receives a view because it needs to know which view to manage. And the view gets the container, which is the view that we just created in the fragment. And that's how the view That's screen events, which is the observable that the fragment is going to use to send events. And the destroy observable, which is the one that we are going to use to protect the view. So here is one line of code. If you need to add that same component in another screen, you are going to copy this line of code and put it there, and that's it. You can have the same functionality, the same business logic, and everything will just work. You don't need to worry about layouts or anything. The component will know how the layout should look like. And now let's go to the presenter. The presenter gets a view, it gets an observable, it gets a destroy observable, and it's going to get that observable, and the first one is take until. Let's not do anything with the view if the fragment is not valid anymore. So that's what's going to protect all the views. And then we subscribe. When we get an event, we check its type. And then we apply the required business logic to that type of event in the context of this component. So for types, we use Kotlin sealed classes, which is very nice for that. We can have objects that are very cheap, or if we need to add variables to the events, we can use classes. It's a little bit more expensive because you have to instantiate an object, but it could work. So here we have an example. We just got a play started event from the fragment. The fragment got something from the player engine, the playback started. Communicate that. So the fragment fires it. Oh, and by the way, the fragment doesn't need to loop through all the presenters and tell them the playback started. It will fire a single event, and all the presenters are observing to that same observable that has the event. And here, what do you guys think that should happen if the playback starts? What the view should do? The view will show itself, because this is how our player works. When playback starts, we show all the UI controls. And then we hide that based on a timeout and etc. But this is what happens, and this is what this view is doing. It's calling the view interface, the presenter is calling the view interface to show it. And what should we do if the player is buffering? We do the opposite. We hide it, because when the player is buffering, the UI controls doesn't make sense because the user can't do anything. It's buffering. We need to wait the buffering to complete, and then we can show the UI again. However, if it's buffering, we want to show the view, because that's the one that we are going to show the spinner. Closing, closing, closing. There you go. So the view, it gets the container from the fragment, and then it's going to inflate itself using its own XML inside this container. And it also provides an interface to the presenter, and may or may not have the animations implemented on it. It's a good place to isolate all the animations, and then you know exactly what that view do when the show is invoked. It controls its own animations. You don't have to apply that in other places and etc. So that's the code. That's how the code looks like. Now we also want to see the testing part, because this is very important for us, and this is one of the reasons why we started to create this architecture. If we have all the code inside a fragment, it's very hard to test. There are a lot of Android dependencies, and you have to mock context, you have to create a fake activity, and it's all very hard. So here, with this architecture, the presenters are the ones that have the business logic. So the presenters are the ones that we want to test. And how do we do that? It's very easy, because as I said before, the presenters are a Java class. They don't know anything about Android. So what we do is they react to events. And then we are going to send some fake events from the test. We create the published subject, that it's an Rx thing that we can use to send events. And we create a mock of the view using Mockito, because we really don't need an instance of the view. So a mock should be fine. And then we instantiate the presenter, the real presenter. That will be a real instance that will run the code. And we pass the mock view and the observable for it. Let's test it. So we are firing a player started. We don't need a player engine to do that. We don't need anything. It's just a unit testing. So what should happen with the view when the play starts? Anybody? Yeah, there you go. We show it. So we verify if the UI view.show method was called once. And this is the expected result. We use Mockito to do that. It's very nice. And now we have the buffering. What should we do with the view if the buffering happens? We should hide it in this context. So the hide is called once, and that's it. All the business logic that we had inside that presenter is now tested. 100% coverage. Okay, let's see some code about the user interactions. When the user taps in a button, or if the user drags something around, or double tap, all these things. So as I said before, we have the screen events observable, that it's everything that happens with the player. We send to the presenter. The presenter communicates with the view using an interface. And now let's see what happens when the user taps in a button. When the user taps in a button, the view fires an event, intent tap, or intent tap something. And then the fragment is going to get that. Let's see how the view does it. The view owns a published subject with UI event or user interaction event types. And we are going to set the click listener in the Android view. That's the UI view owns. And then it's going to fire. Intent pause. That's a pause button, right? Let's say that we have a pause button. We are going to fire intent pause. Somebody tapped me. And then the fragment is the one that's going to observe and subscribe to these things. And here, remember that the fragment owns any presenters. It could be 20 presenters, or depending on how many components you have. So what we do is we create an observable in the fragment that merges all the UI event observables from all the views. And then what we do is we subscribe to it, we check the type. If the type is pause, the fragment is going to invoke the player engine and pause it. So think about how it would look like if your view had to do that. We probably will have to send the fragment reference all the way to the view, or the player engine reference all the way to the view, and we'll have to add 100 lines of ifs to make sure that's not going to blow up. And here is super clean. The view doesn't have anything. So let's close everything. And now let's talk about layouting. Layouting is, we talked about how do we use the layout of how the components view on its own layout. But then it's isolated for that component. It's only applied for that component. How do we create a screen? The screen is formed for 20 components or 15 components in the case of the player. We have to align everything together. We have to make it work. So what's the approach that we use for layout? If you have a simple screen and the parent or the container that the fragment owns, it's a linear layout, it's pretty easy because every single component is going to inflate itself and it will create that. So it's the order that you instantiate your views that it's going to decide what the layout will look like. And that could be very useful for a simple screen. If you have a simple screen that has some text views and some buttons, you just lay out like that and that's it. If you change vertically or horizontally, it will all work. However, it's not always that easy. If we need to create a complex screen like the player one, we use constraint layouts. And the main container that the fragment owns, it's a constraint layout. So every view will inflate itself inside the constraint layout, and we can set all the constraints programmatically in the code. And then we can say, this component should be in the left of that component, or it should be in the top of this component. And this is how we lay out the whole thing. It needs some programmatically layouting to set the constraints. Okay, let's recap. The takeaways that I have for you are, the first one is, do not pass fragment reference around. That's very dangerous. So try to keep your fragments clean and put the business logic of at least the UI business logic where it belongs. Think about componentization. Think about breaking your UI into small pieces and try to make these things fit together, isolating the code. That will prevent a lot of complexity. Because if you have all the Android views in one place, you are going to hide one, show another one, animate another one, and then when the loading is over, you have to remember that you have to hide the loading and show something else. It introduces a lot of complexity that doesn't exist if you isolate everything in another place. And the next one is use the Wi-Fi and download your shows. Then you can use it later. And then you are going to know when the loading screen shows up, you know what happened. There was an event that was sent from the fragment to a presenter, and the presenter showed that. When the playback started, the loading is gone because the loading component is listening to the events, and it knows that it's not buffering anymore, it's gone. Let's show what matters. And this is how it works. So you are going to look on that and think about this talk, hopefully. And the third one is we are always looking for good engineers. So if you want to know more about the team, just we can talk offline. I can tell you more about our team and what we do and everything that we have there. So in order to close that, I can take some questions. But before, I just want to talk about that URL. So I added a sample of this architecture, a very simple app that you can check out to see how the code looks like. And that's mainly 3 UI components. We have a button, we have a loading spinner, and there is a success and error component, something like that. So the way that it works is the loading component is the one that fires in the calls. When the call is back, we check if it was successful or if it was an error, and then we send the events from the fragment, and all these components that we have will react accordingly. If the error event fires, we are going to show the error view. If the loading event happens, we are going to show the spinner. And all the code is isolated in its own components. So check it out. And we can take some questions.